Problem 2 talks about average prices of single-family properties in Seattle and Port Townsend and between certain years. And what the problem wants us to do is find a linear model relating the year X and the sales price Y for a single-family property in Seattle, given the values in this table. So I started out by recording these values just by hand, and then went ahead and created an equation for Seattle using a point slope intercept. So I got y minus y1, which is 38,000, using this value for y1, equals m times x minus 1970, using 1970 for x1. And then solving for m, getting $6,850. Basically what it's saying is just the value goes up $6,850 for every year past 1970, starting at $38,000. Went ahead and solve for y, and this is what you get. For Port Townsend, I did the same thing, but plugged in 8,400 and, well, it's supposed to be 1970, sorry. But you get y equals 8,000 times x minus 1970 plus 8,400. I went ahead and plotted those on the graph here using these two tables, and that's what the graph looks like. So now it's asking, so that other covers part A and B and C. You'll see that on my graph, I just did years after 1970, so this would be 0 years after, so 1970, and this would be like 1980. And then for the y-axis, I just recorded it in tens of thousands of dollars. So part D asks for the sales price in Seattle and Port Townsend in 1983 and 1998. So I just used our formulas, plugged in 83 and 98 for x, and then solved and got these values here. Part E asks, when will the average sales price in Seattle and Port Townsend be equal, and what is this price? So all you have to do is set the two equations equal to each other. This I was getting really tired of using large numbers, so instead of doing 6,850 times x minus 1970, I just did 6,850 times x, given that x is the number of years after 1970. So I just add 1970 at the end of the problem in order to get the right solution. But anyway, so we have 6,850 times x plus 3,800 equals 8,000x plus 8,400, set them equal to each other, solve for x. We know that 25.7 years after 1970, or 255 days into 1995, the sales price will be the same at $214,319. For F, when will the average sales price of Port Townsend be 15,000 less than the Seattle sales price? What are the two sales prices at the time? So similar to the last problem, we go ahead and set the two equations equal to each other, but now we want it to be 15,000 less, so we subtract 15,000 from one side of the equation, and then solve for x, and we get 12.7 years after 1970, which is 1982 and 254 days. The Seattle price is 125,000, and the Port Townsend price is 114,000. Part G asks, when will the Port Townsend sales price be 15,000 more than the Seattle sales price? What are the two sales prices at this time? So we do the same thing as we did last time, except we add 15,000 and solve for x, and you have the Port Townsend price is 318,000, 303,000 for Seattle, and this is in 2008 and 284.7 days. Part H asks, when will the Seattle sale prices be double the Port Townsend sale prices? We take our original, multiply the Seattle prices by 2, set it equally to each other, and solve for x, and you get looks like I forgot to do that part, but oh no, 2.3 years after 1970, which is 1972 and 109 days, and it'll be $53,700. Okay, last question asks, is the Port Townsend sales price ever double the Seattle sales price? And the answer is no. Maybe 11.85 years ago it was, but in the future it's not going to happen again.